Have you ever wondered what makes artificial intelligence different from the software you use every day? Your calculator, banking app, accounting program, and many websites are all software. AI systems are also built with software. So, what's the difference? In this lesson, we'll explain it in simple language. The easiest way to understand the difference is to think about three things: rules, data, and learning. Traditional software generally follows instructions and rules created by programmers. Machine learning systems, on the other hand, learn statistical patterns from data and use those learned patterns to produce predictions or other outputs. Let's start with traditional software. Imagine a simple calculator. You enter 10 plus 5. The software follows the programmed mathematical rules and gives you 15. The computer doesn't need to learn addition from thousands of examples. The instructions already tell it how to perform the calculation. This is the basic idea behind many conventional software systems.
Traditional software works particularly well when the rules of a task can be clearly defined. Examples include calculators, payroll systems, accounting applications, inventory systems, website forms, and many business applications. When the instructions are clear, conventional programming can be a powerful and reliable solution. But what happens when the rules become difficult to define? Imagine trying to create software that can recognize whether a photograph contains a cat. You might try to write rules: fur, 2 eyes, pointed ears, whiskers, a tail. But real photographs aren't that simple. The cat could be partly hidden. The photograph could be dark. The cat could appear from an unusual angle. Suddenly, writing a rule for every possible situation becomes extremely difficult. This is one situation where machine learning can be useful. Instead of manually writing every possible rule, a machine learning system can be trained using many examples. For example, cat image, cat. Another cat image, cat. Dog image, dog. Another dog image, dog. During training, the model learns statistical patterns from those examples. After training, it can receive a new image and produce a prediction.
This gives us one of the most important differences between traditional software and machine learning. With traditional software, humans explicitly define the rules, and the computer follows them. With machine learning, humans provide data and design the learning system, and the model learns patterns from that data. The result can then be used to make predictions or produce other outputs. Let's look at another example: spam email. A traditional approach might use explicit rules. For example, if an email comes from a blocked sender, mark it as spam. Or if certain conditions are met, move the message to the spam folder. These rules can work well, but spammers can change their wording and create new patterns. A machine learning system can instead be trained using examples of spam and legitimate emails. It can learn patterns that help classify new messages. So, is AI better than traditional software? Not necessarily. This is an important point. AI isn't simply a replacement for traditional software. If you need a system to calculate a salary according to clearly defined rules, conventional software may be the better choice. If you need a system to follow a precise formula, traditional programming can be reliable and straightforward. Machine learning becomes particularly useful when we are dealing with complex patterns that are difficult to define manually.
And here's something very important. It isn't always AI versus traditional software. Many modern applications use both. An online shopping platform may use conventional software for accounts, payments, orders, and security. At the same time, it might use AI for product recommendations, fraud detection, search improvements, or customer support chatbots. So AI and traditional software can work together. Instead of asking, "Is AI better?" ask, "Which approach is appropriate for this problem?" If the rules are clear and predictable, traditional software may be ideal. If the task involves complex patterns that are difficult to define manually, machine learning may be useful. And sometimes, the best solution is to combine both. Let's review. Traditional software. Humans define the rules. Machine learning. Models learn patterns from data. Traditional software is excellent for clearly defined tasks. Machine learning can be useful for complex pattern-based tasks. And many modern systems use both. AI and traditional software are not competing technologies. The goal isn't to use AI everywhere. The goal is to use the right technology for the right problem. Understanding this difference is an important step toward becoming a smarter AI user.
This is AI Success Academy. Learn, practice, create, grow. In the next lesson, we'll explore machine learning explained simply.